So question 4 says determine algebraically. So when you see algebraically for inverse, you're thinking, I'm going to switch the x and the y and solve for y. Determine algebraically whether the functions are inverses or not. So in part I have y equals 3x minus 6. And if algebraically I want to find its inverse, I would switch x and y and solve for y. So I'm going to move the 6 over, divide everything by 3. There's my inverse. Does it match with the one that they provided? Are those equations the same? Is x plus 6 divided by 3 the same as x minus 6 divided by 3? No. Because one is plus 6 and one has minus 6. So we make a note between this one and this one. They are not the same. That means they are not inverses. They would have to be identical to make them inverses. To verify your answers graphically, so we'll do that for this one right away, we are going to graph y equals 3x minus 6 in blue, and we are going to graph y equals x minus 6 over 3 in green, which is the same as the green one right? I can divide the x by 3, which would give me 1/3 x. I can divide the 6 by 3, which would give me minus 2. Why did I change it to those forms? So that we would have y equals mx plus b for both of them. I'm going to graph the blue one. And the blue one has a y-intercept of minus 6 and a slope of 3, meaning I would go up 3 over 1, up 3 over 1. I can label these points 0, negative 6, 1, negative 3, 2, 0. Those are 3 points on my blue graph. My green graph has a y-intercept of negative 2 and a slope of 1/3, meaning it goes up 1 over 3, up 1 over 3. And I can label these points 0, negative 2, 3, 1, 6, 0. Graphically, we can tell that these are not inverse graphically. For one, if here is the diagonal line, y equals x, the blue one definitely has not been flipped over that to match the green one. Graphically, if the blue one has 0, negative 6, then the green one should have negative 6, 0, switching them. But graphically, that doesn't happen. So we have a number of ways graphically that we can say that these are not inverses. So all right if I scroll up? Everybody ready? Not quite? second one, we have y equals negative x squared plus 3, and this comma here is a domain restriction. We're only taking half of the parabola. Graphically for this one, off to the side, just going to do a quick imagination. Can you see this parabola has a vertical reflection and then has been translated up 3 units, which would make the parabola look like this, and we are only taking the half where x is bigger than or equal to 0. Algebraically, if I switch the x and the y, okay? If I switch the x and the y, I would have, I'll just write out, find the inverse. I'm going to have x equals negative y squared plus 3. I want to get the y squared by itself. I'm going to subtract 3 on both sides, then multiply by the negative 1 so that the y squared is completely by itself. I can now square root both sides. I have to remember the plus or minus. But now with the domain restriction, we have to decide, does the domain restriction make it the positive ones, or does the domain restriction make it the negative ones? Okay? When we looked at it in our example before, we looked at it graphically. So graphically, I hope that you can see that the original graph had 0, 3. And if I found another point on here, for example, if I plug in 2, I would get 2, negative 1. Graphically, I would now have on my inverse 3, 0, and I labeled the point wrong. I would have 3, 0, and negative 1, 2. Right? Switching the x and the y. Does that have a vertical reflection? No. It's had a horizontal reflection, but not the vertical reflection. So based on my graph, I would have y equals negative x plus 3. Does that match up with what they have? They have 3 minus x. I have negative x plus 3. This is the same. So we can say, yes, they are inverses. If we wanted to prove it graphically, we would have to graph, which we've graphed the blue one already, but we would have to graph this negative x plus 3. How do you graph? And I'm going to graph it in green. It would start like this. This is how the equation they gave us. 3 minus x. 3 minus x is the same as negative x plus 3. I see a horizontal reflection, but this is not in factored form. I have negative 1, x minus 3. This is a square root with a horizontal reflection and moving 3 to the right. So when I go to graph both of these on the same graph, for this green one, I would take my square root graph, horizontal reflection, and then move it 3 to the right. It would look like this. My blue graph was originally a parabola, but only this part. And when we graph these both, we can see that they are a reflection over the diagonal line. And we can also see that certain points, like on the blue one, we had 0, 3. On the green one, we have 3, 0. So graphically, these ones are inverses of each other. Now I said I would like to do another example like example 3 with you, so I'm going to actually steal the Is everybody done with example 4? So let's do another example like this. I have one on your take-home quiz that you're going to get tomorrow. And for you, you have a blank page on page 251. So if you want to write this one down on a blank page, you can go to page 251 and write this example down. So we'll do another one. Determine 2 ways to restrict the domain of y equals x squared, x minus 2 squared minus 4, so that the inverse is a function. And on your quiz, I'm going to give you 2 graphs, sort of already splits your question up in 2 different ways. But I'll let you catch up with writing it down if you're writing the question down. So again, there's 3 things that we have to do for each one. So 6 things in total. We have to restrict the domain, find its equation, and show it graphically. First of all, off to the side here at the top, can you see that this is a parabola that had been moved 2 to the right and 4 down? If I took this parabola and shifted it 2 to the right and 4 down, I would get a vertex right here at 2, -4, and it would be going up like this. So now, in my 2 sections, the first thing I need to do for both of them is restrict the domain. I'll do this one in blue, this side in green. The domain restriction, we want to restrict the domain to make it a function. So it has to pass the horizontal line test. You will always use your vertex to restrict your domain. So this time my vertex is at 2, -4. So for my blue one, I'm going to take x is bigger than or equal to 2. So I'm going to take the right half. And for the green one, I'm going to take x is less than or equal to 2. That's the left half. Graphically, we can start by graphing I'm going to take 2, -4, and I'm going to take this half of the graph for my blue one. Graphically, for my green one, I'm going to take, still have my vertex, 2, -4, but now I'm taking that half of the parabola. Graphically, I'm going to draw my inverse for both of them in purple. If I have 2, -4, on my inverse, I would have -4, 2. And if I take another point that I have on my graph, for example, I have 4, 0 on my graph. If I switch x and y, on this one, I'm going to have 0, 4. On my second one, if I want to show the inverse graphically, on the second one I have -4, 2. That's still going to be the same. But I'll also have 0, 0. Now I've used the graph to illustrate both ways. The last thing I need to do is write the equation of the inverse for both of them. Okay? How do we find an equation of their inverse? We are going to switch x and y and solve for y. So if I switch x and y, I'm going to have x equals bracket y minus 2 squared minus 4. I can add 4 to both sides to get the squared by itself. Square root both sides. And finally get y by itself. By adding 2 to both sides. Okay? Now, we have to figure out which equation goes with which. So I've done the work on this side, but I did it in black because it's actually worked for both of them. If I want to find the equation for this side, can you see that the purple is a positive? There's been no vertical reflection for that square root graph. So the blue one's equation is going to be the positive x plus 4 plus 2. And the green one, its equation is going to be the -1 and now we have the equation for both sides. So on your quiz and on your test, I'll give you I'll split it up with 2 graphs, and this is what I would expect you to be able to do when we split it up with 2 graphs. Okay?